Section 5.5, example 1, using the remainder theorem to evaluate a polynomial. So use the remainder theorem to evaluate the function at x equals -2 or x equals 2. So what the remainder theorem tells us is that when we divide out a value, the remainder ends up being our function evaluated at that value. So let's give it a try. So we have 2 and we have our polynomial. Let's make sure that it's in standard form and that we have a representative for each of the terms. So we start off with our highest degree, x to the power 4, 3, 2, that's supposed to be 2, 1, and x to the power 0. So it looks like we have a term or a value for each of the terms. So let's go ahead and put it in our synthetic division. 6, -1, -15, 2, and -7. So once we finish, this is going to be our remainder. And just like we did before, we bring down the first term. Then we have 2 times 6 is 12, minus 1 is 11. 2 times 11 is 22, minus 15 is 7. 2 times 7 is 14, plus 2 is 16. 2 times 16 is 32, minus 7 is 25. So here, this tells us that f evaluated at 2 is going to be equal to 25. And just to make sure, let's give it a try. So we're evaluating our function at 2. So 6 times 2 to the power 4 minus 2 cubed minus 15 times 2 squared plus 2 times 2 minus 7. And just so we don't mess anything up, let's use our calculator. So we have 6 times 2 raised to the power 4 minus 2 raised to the power 3 minus 15 times, minus 15 times 2 to the power 2 or squared plus 2 times 2 minus 7, and wow, that gives us 25. And we just proved it by actually computing everything out. But the remainder theorem does tell us that this will always be true here. And there you go. If you have any questions, please feel free to ask. Otherwise, bye.